standing by. The call will begin momentarily. Thank you for standing by. The call will begin momentarily. Again, thank you for standing by. The call will begin momentarily. Thank you for standing by. The call will begin momentarily. Thank you for standing by. The call will begin momentarily. Thank you for standing by. The call will begin momentarily. Welcome and thank you for standing by. I would like to inform all participants that your lines have been placed on a listen-only mode until the question and answer session of today's call. Today's call is being recorded. If anyone has any objections, you may disconnect at this time. I would like to turn the call over to Catherine Hambleton. Thank you. You may begin.
Thank you and good afternoon. I'm Catherine Hambleton with NASA's Office of Communications. NASA has completed stacking its Mega Moon rocket for the Artemis 1 mission. It now stands 322 feet tall inside the vehicle assembly building as it enters the final phase of testing before launch. Artemis 1 will be the first in the series of increasingly complex missions that will pave the way for missions with astronauts as we prepare for human missions to explore Mars. Here to talk with us about the recent operations and what is ahead of us before the Artemis 1 launch are Tom Whitmire, Deputy Associate Administrator for Exploration Systems Development at NASA headquarters, Mike Bolger, Exploration Ground Systems Program Manager at NASA's Kennedy Space Center, Kathy Kerner, Orion Program Manager at NASA's Johnson Space Center, John Honeycutt, SLS Program Manager at NASA's Marshall Space Flight Center, and Mike Serafin, Artemis Mission Manager from NASA headquarters. After a brief opening comments from each of our speakers, we will take your questions. You can enter *1 on your phone to be entered into the question queue at any time. Your phones are on mute now, and the operator will open your mic when we're ready and close your mic after you ask your question. We ask that you please stick to one question and identify to whom your question is directed. If we have additional time, we'll do another round of questions. About 1 hour after we conclude, you can listen to a replay of this teleconference by dialing toll-free 202-369-0188. All right. And first, we'll hear from Tom Whitmire. Tom?
Okay, thank you, Catherine. Hey, I just got back from the Kennedy Space Center. I was down there on Wednesday. I had a chance to be with Mike Bolger in the vertical assembly building. And what we do is we go into the building, and if you go all the way back and to the right, that's High Bay 3. That's where this vehicle is. And Mike and I were over in High Bay 4, which is across from it. And we got to see the 322-foot tall integrated stack. And it's taller than the Statue of Liberty, and I like to think of it as a Statue of Liberty because it's very engineering complicated piece of equipment, and it's very inclusive. It represents everybody. As you know, Artemis 1 is the first step to landing the first woman and the first person of color on the moon, and it's a very important achievement for this country. The rocket itself was built using people from every state in the United States of America, and it also involved a partnership with the Europeans, and we're very proud of that. And so before I get started, I just want to take this opportunity to thank all those folks who did all that work to put us in a position as a country to be able to do this next step as we move forward with the Artemis program. So thank you very much. So we've got the integrated stack and the VAB, and we will start to check all the interfaces across the rocket and make sure that they are working properly. They're communicating with each other, and they're communicating with our Launch Control Center. Mike Bolger, who will talk in a few minutes, will give you more details about the testing that's in front of us. I can tell you overall from an agency perspective, we're looking to get to the pad late this year, and then early next year we will do a wet dress rehearsal. After the wet dress rehearsal, we go back into the VAB, back to High Bay 3, and we do some additional checks outs, and then we'll roll it out one more time, and we'll be prepared to launch the vehicle. And we're looking for a period of time right now for an analysis purposes. We're looking at a period of time within February. Mike Serafin, who's here with us today, will talk a little bit more about those period of time. But in generally speaking, we're very excited. We think this is really tremendous progress, particularly during a period of time where we've had some COVID challenges and other activities and some first-time flow challenges. We're really proud of the dedication of the team, Mike's team, and everybody involved in the process. Artemis 1 is a test flight. It's not crewed. It's our opportunity to bring SLS and Orion up in deep space, take it to the moon. When I flew back after Wednesday, I came in on a plane, and I was on the right side of the plane, and I looked out my window, and it was a clear night, and we had the Hunter moon was out there. It's right at the horizon. And I think everybody who could have been there or saw the Hunter moon themselves, I hope you kind of thought about that for a few seconds and the silent promise that we have to get back to the moon, take our next step, and have the first woman and the first person of color on the lunar surface. We think that's really important. Like the Statue of Liberty, I think it really represents what this country is about. And with that, let me go ahead and introduce Mike Bolger. Mike Bolger is our ground processing lead, our program manager for EGS. Go ahead, Mike.
Yeah, hey, thank you, Tom, and good afternoon, everyone. You know, Tom, it's interesting. I saw the moon, too. We had clear skies here as well, and it's funny. Anytime there's a full moon, I look up there and I kind of think about the mission that we've got, and it always gets me pumped up. And this is a really exciting time to be a part of the SOS, Orion, and Exploration Ground Systems team. Here at KSC, we've been preparing for this moment. You know, we've been upgrading our facilities. We've been developing new ground support equipment. We've been writing the software and preparing the team, and now we're ready. And the team has been working around the clock, and I'm really proud of what we've accomplished already. Earlier this year, we stacked the solid rocket boosters, and then in June, we added the core stage and the launch vehicle stage adapter to the stack. We added the interim cryogenic propulsion stage in July and began hooking up all the umbilicals that provide the power and the comm and the coolant and the fuel to the rocket. In August, we started powering up the rocket, first one element at a time, and then as an integrated launch vehicle. And then in September, we performed an umbilical retract test where we ran through a launch countdown and proved our capability to retract all of the umbilicals at T0, ensuring that we'll have the appropriate clearance on launch day. Right after that, we attached shakers and sensors and conducted an integrated modal test and shared that data with the SLS program. Both those tests were really successful. While that was going on, in parallel facilities here at Kennedy, we were fueling the Orion spacecraft and readying it for flight. The launch abort system has been installed on top of the crew module, and the complete Orion system was transported over to the VAB earlier this week and stacked on top of the SLS rocket. Not sure if the pictures are all out there yet, but like Tom said, it's a heck of a sight, and it is really nice to see. And he said we went to High Bay 4. We went to High Bay 4 because the rocket's so big that to fully appreciate it, you need to get a little bit of distance from it to actually see it kind of top to bottom. And even then, we had some of the VAB platforms extended, so we had parts of it obscured. I'm really, really looking forward to the first day when we roll out of the VAB to the launch pad and kind of seeing it in all its magnificence, because it's a heck of a rocket, and Orion's a heck of a spacecraft. So looking ahead, we're in the process of reconnecting all the umbilicals and getting ready for the integrated verification tests that ensure the flight hardware and the ground interfaces are working. We'll start with the Orion power-up this weekend, and then we'll follow up during the month of November, powering up the core stage and the second stage again, and then the entire integrated launch vehicle. As we get into the first week of December, we'll conduct a communications end-to-end test where we'll verify all the communication systems are operating on the ground and in the flight phase. And then teams in Fireroom 1 and the LCC will perform a countdown sequence test before the fully stacked SLS rolls out to pad 39B for wet dress rehearsal. During that test, SLS and Orion will be configured for launch so that the launch team can execute the launch sequence on the integrated system as a risk mitigation for the wet dress rehearsal. So we've been really busy, and we're going to stay busy for a while, and that's the way we like it. We talk a lot as a team about appreciating the moment and about being thankful for this opportunity that we've been given. We recognize the responsibility that comes with being entrusted to prepare the Artemis 1 flight hardware for launch. We do this very much as an integrated team. It's EGS, it's SLS, and it's Orion, and it's all of us working together, and we work really well together. So with that, let me turn it over to Kathy Kerner, the Orion Program Manager, who'll offer a few words as well.
Yeah, thank you, Mike. Good afternoon. These past few days and really the last week have been extremely exciting for the Orion program. Not only has the spacecraft successfully joined the Artemis 1 stack with the SLS rocket, which brings us that much closer to launch, but we've also had deliveries of other Orion elements for Artemis 2 and Artemis 3 to the Kennedy Space Center. I'm thrilled with the expertise and the dedication that our teams have displayed in building these vehicles and getting them all to Kennedy. We've done extensive testing with Orion to ensure that the spacecraft was ready for our rollout and then joining with the rocket, and so now we'll be operating Orion systems jointly with the rocket, which will allow us to gather more data for Orion's development work and confirm that we're ready to fly. With this first voyage of Orion and SLS, we'll prove out the vehicle design, take all of the experiences from this test flight, and then carry those forward to upcoming Artemis missions, refining our processes and efficiencies and making the changes when necessary. This will be Orion's second trip to space, but the first time into deep space, and it'll be much longer than our first mission, EFT-1, a much more rigorous mission to the moon, which is 1,000 times farther from Earth than where the space station flies today. And really will demonstrate our capability of our spacecraft in a more extreme radiation environment. We're looking forward to sending Orion off to the moon and watching it perform in the environment it was designed for. The folks that got us to where we are today are the definition of teamwork, and I'm extremely proud of their collaborative achievements, collaboration both domestically but also internationally, building the spacecraft that will eventually take humans farther into space than ever before. With that, I will hand over to the SLS Program Manager, John Honeycutt. John?
Okay, thank you, Kathy, and good afternoon, everyone. I'll tell you, I've been very, very impressed just watching the entire stacking and integration that Mike and his team have done in the VAB. We've had, like Mike said, quite a bit of involvement in working as a team across the whole enterprise, and seeing the SLS system come together over the last few months now with the Orion on top gets us to a place where we're ready to finish up the testing and the integration work that we've got to do and head to the moon. I've watched the team over time go through many learning experiences and lessons learned in assembling the rocket and Orion, and I think it's put us in a really good place for the future. We got a strong learning organization, and we've learned a lot about how to put the rocket together, and I think it's gone really, really well. Along with putting the rocket together, and you'll hear more about this later, but, the entire team across the enterprise has gone through several mission simulations and other ground operations that are preparing the team that's going to undertake the historic Artemis 1 mission. Artemis 1 is the first flight of SLS with Orion. First flight will be a test flight. It'll be the first use of many of these ground systems as well as SLS and Orion. So, we're learning a lot about how to put the rocket together, and the work that we're completing over these final days, for the mission. I'll tell you, I couldn't be prouder of the team that got us to where we are today. Despite the multiple challenges that we faced with COVID and major storms, most recently from Hurricane Ida, and the impacts that it's had on our production facilities, the team, and that includes our industry partners as well, and they've all pulled together and made that happen. We did see really, really good success, as Mike alluded to, in the recent modal testing, and we walked away with a tremendous amount of data, and important data that informs us on how the rocket will perform during flight. And so we'll be working closely with Mike as he goes through his series of tests and gets us to a wet dress rehearsal, and I'm really looking forward to that. So now I'd like to turn it over to Mike Serafin, who is our mission manager. Mike?
Thank you, John. Completing stacking is a really important milestone. It shows that we're in the home stretch towards the mission. In parallel with bringing our rocket and our spacecraft together at our launch site, we've been bringing our mission teams together. So that's our operations teams led by the Exploration Ground Systems for launch and recovery out of the Kennedy Space Center, our flight operations team out of Mission Control in Houston, our engineering teams that are the engineering technical reachback for the Space Launch System out of Huntsville, as well as the Orion spacecraft in the mission evaluation room out of Houston, and then the mission management team. So we've been coming together as one mission team in parallel with our hardware at the launch site. We've conducted a series of simulated missions, and I can promise you that we are on track to fly, and this team will be ready when our flight hardware is ready. We've got some challenging mission priorities ahead of us. We've purposely pulled together a stress test for our Space Launch System rocket in our Orion spacecraft, and our 4 primary objectives are to demonstrate Orion's ability to return from the moon at lunar reentry conditions, to operate our flight systems in the flight environment, to retrieve our spacecraft, and then what I like to call bonus objectives. If you break those down a little bit further, in order to demonstrate Orion's ability to return from the moon at lunar reentry conditions, we need the rocket to do its job. We need to take all that cryogenic fuel and solid propellant and chemical energy that we have on the ground and deliver the Orion spacecraft to the point of translunar injection, and then take all that potential and kinetic energy out through friction when the spacecraft enters through the Earth's atmosphere. And while we've already demonstrated Orion's ability to fly and re-enter during Exploration Flight Test 1, when we come back from the moon, it's going to come back far faster and far hotter than we did on that high Earth orbit mission. If we break down priority number 2 a little bit further, operating the systems in the flight environment, we need the rocket to fly up through the Earth's atmosphere, through maximum dynamic pressure, and deliver Orion to the point of translunar injection through the boosters, through the core stage, through the interim cryopropulsion stage, all the critical separation events to work. And then as Orion heads outbound towards the moon and then returns, we need to head out through the micrometeoroid and orbital debris environment that encircles the Earth. We need to head out through the Van Allen radiation belts and the Earth's magnetic field and out into the deep space environment. We need to propel and power ourselves in the deep space environment where it's far colder than we see in low Earth orbit. We need to communicate and navigate above the global positioning navigation satellites that most terrestrial and low Earth orbit users use to navigate, and we need to communicate in the deep space environment in and about the moon. So we only for a short period of time have the space network and the tracking and data relay satellites available to us to command and control and communicate with our spacecraft. So we're going to be using the deep space network to do all that. Our number 3 priority, if you break that down a little bit further, retrieve the spacecraft. That is an important objective because we physically get Orion back. We get to look at the heat shield. We get to see if there were little hot spots or erosion that weren't picked up by the flight instrumentation that's buried in the base heat shield that we're going to gather data on. We get the onboard recorded data, that's imagery, as well as flight instrumentation that is captured on board, including during the peak heating period, which has a communications blackout coincident with it as we come back for about 2 or 3 minutes back into the Earth's atmosphere through that peak heating period and slow our spacecraft from Mach 32 to 0 in the course of 20 minutes. We also get back the spacecraft's high-precision avionics for a programmatic savings and reflight on other missions, and then the spacecraft structure itself for structural testing post-flight. And then priority number 4 is what I like to call bonus objectives, or to complete our remaining objectives. It's a whole host of activities that are important, but if we don't fully accomplish them, have no material impact on our ability to fly astronauts on subsequent missions. So those are things like deploying 10 CubeSats, each on their own science or technology mission, from the spacecraft adapter that flies on the nose of the interim cryopropulsion stage. It's gathering radiation data for what future astronauts might experience as they fly outbound to the moon or return through the Van Allen radiation belts, through a whole host of radiation sensors and some phantoms on board that are going to monitor what the conditions will be like. And then we're going to bring the public along. We're going to bring each and every one of you along from end to end for this mission throughout day of launch as we head out through translunar injection out toward the moon, in our journey between the Earth and the moon as we encircle the moon, and then come back home, and then entry and day of launch or day of landing and splashdown and recovery. We're going to see some remarkable photos from the wingtip cameras mounted on the ends of the solar array wings. Orion is going to take selfies of itself, and we'll see the moon in the background, and way off in the distance at its farthest point, we're going to see the Earth some 270,000 miles away, and really gain a new perspective for the Artemis generation. So we've got a lot of content packed into this mission. We aim to accomplish all of it, and we've got clear priorities set out to do that. As part of getting ready, our team ready for flight, we've conducted, as I mentioned earlier, some recent simulations. We had our full team as recent as last week. I was down at the Kennedy Space Center and the Launch Control Center, and we did a terminal countdown simulation followed by an ascent through translunar injection sim. And that was a fantastic learning opportunity. Our teams are definitely on track to be ready for day of launch. In early November, we have underway recovery test number 9 coming up, which is a full mission dress rehearsal with air operations, with helicopters, small boats that will be used to initially assist the retrieval of the Orion crew module, and then the recovery ship itself with our Navy counterparts. So We've got all the teams working together to be ready for flight. We've got our wet dress rehearsal ahead of us, and that's an important milestone as well because we'll be getting ready for day of launch there. We'll have our flight vehicle at the pad. We'll load it with cryos. The only thing we won't do on that day is to launch, and that's purposefully so we can test like we fly, and we're also training like we intend to fly. As we head towards our launch window here that Tom Whitmire mentioned earlier, we do have a roughly 15-day launch period in February. Half of those are what we call long class missions. Duration is about 6 weeks, where we'll spend a little bit of extra time in the distant retrograde orbit to set up landing lighting conditions at the splashdown zone. And then the second half of that window is what we call short class missions, which is about 4 weeks in duration. We know exactly the duration of each mission opportunity. It's day dependent, and it's really tied to some of the objectives that we have. So our teams are off preparing for these scenarios and all the various mission phases, and the specific mission duration again is going to depend on the day that we launch. So we've got all the right team members in place, and we're on track to ensure that we'll have a successful mission. So that's it for me, Catherine. I'll turn it back to you.
Thank you, Mike. We'll now begin the question and answer portion. Please remember to stick to one question and identify to whom it is directed. If we have time, we'll allow reporters to ask a second question. Again, you can enter *1 on your phone to be entered into the queue at any time, and you can enter *2 if you'd like to be removed from the queue if your question is answered while you're in the queue. All right, so first we will start with Bill Harwood from CBS News.
Yeah, hi guys. I think this is maybe for Whitmore. For Mr. Serafin, I'm not sure. And pardon me, my voice is a little messed up this morning. Can you tell us when the February period, the launch period, begins and ends? And is there a target date for the wet dress rehearsal? I appreciate that. Thanks.
I'll take the first part of that one, Tom. So this is Mike Serafin. So the February launch period opens on the 12th, and our last opportunity in February is on the 27th.
Okay, Bill, in terms of the wet dress rehearsal, we're looking to do it earlier in January. We don't have a specific date set right now. We've got a number of steps we've got to do to get ready for that test. But right now, that's the time frame we're thinking about.
Thank you very much.
Our next question is from Stephen Clark of Spaceflight Now.
Your line is open.
Hi, Stephen Clark, Spaceflight Now. Just to follow up on Bill's question, I'm wondering if Mike Serafin also has the dates for the follow-on launch periods in like March and April, and do you happen to know the launch time if the launch were to occur on February 12th? Thanks.
Yeah, hi, Stephen. Yes, we do have what we call a rolling analysis cycle that, if we don't make the February launch period, we're going to be prepared and have that trajectory data and the mission plans in place should we need that. Roughly the pattern that we've got is we're on for roughly 2 weeks, and then we're off for about 2 weeks, and then on for 2 weeks, and then off for 2 weeks. And it really has to do with the three-body problem that we're dealing with. We have the Earth rotating on its axis. We have the moon going about the Earth in its lunar cycle, its 28, 29-day lunar cycle, and then we've got to head outbound and then splash down at a set of daylight landing conditions. And with the intercrowd propulsion stage, we at certain points in that lunar cycle are performance constrained. This is not a problem that we have when we get to the more powerful exploration upper stage as part of the Block 1B upgrade that's in front of us. But when we get to the March launch period, our opportunities open up on March the 12th and close on the 27th. And then April, should we need that again, would open on the 8th and close on the 23rd. The launch window open time you asked about on February the 12th, I've got here is 5:56 p.m. Eastern.
And Mike, how long's the window for that?
The window is 21 minutes. And the longest window that we have, is, again, is day dependent. The longest window duration is 2 hours or 120 minutes. So the window duration varies based on the day that we're going, but its maximum window is 120 minutes.
Yeah. Steve, we've talked about this a lot. It's really crazy. The moon moves around on you. When I saw the Hunter moon on Wednesday, it was off on the east, and Mike and I walked to work Thursday morning, it was off to the west. So it's going to be very interesting because we got this three-body problem, and it drives a lot of our decisions in terms of when we launch, and it'll move around, and windows will get bigger and smaller. So it's a good question.
Thank you. Our next question is from Michael Sheets of CNBC.
Hi, this question is primarily addressed to Tom Whitmire. I'm curious, given this is a taxpayer-funded program, what NASA's estimated total cost of the Artemis 1 mission is? Thanks.
Yeah, we have, of course, we're really a transparent agency. We have a lot of reports out there right now, and I'd kind of reference you to them. There's different ways to look at the cost of the mission, whether it's the development cost, the test cost, operational cost. I would really just refer you back to what's publicly available information in that area. It really depends on how you ask the question, and so that would probably, I don't want to give you a number that's any different than already out there, and I think there's a number of reports right out now that you can just take a look at and see what they've got.
Thank you. Our next question is from Eric Berger of Ars Technica.
Your line is open.
Excuse me. Hi. Thanks very much for doing this. Probably a question for Tom Whitmire, but maybe Mike Serafin. Can you talk about what will be different from this wet dress rehearsal versus what was done in December 2020 during the green run tests? Should we expect that since you've been through this process a couple times now at the core stage that this process will be fairly smooth, or lots of things going on that maybe make it a little more challenging and sort of, experimental in that sense? And then when would you need to be complete with this wet dress rehearsal to meet that February launch window? Thank you.
Okay, Eric, let me start, and I'll let Mike Bolger kind of add some more details. He's the expert for the ground processing activity. What we did at Stennis was really a test of the vehicle, and John Honeycutt would do a much better job than I would describing all the different system parameters that were demonstrated in the core stage performance. It was an excellent test. Actually, the core stage performed very well. When we're at the Cape and we get out to the pad, we have to demonstrate the systems that are at KSC in terms of their interface with the vehicle. We want to see how the ML performs. We want to practice our cryosphere loading and unloading. We go through a couple operations for this wet dress that we would do differently for the actual launch. And we have a lot more flexibility because we can work issues and demonstrate all the systems and end-to-end system integrity all the way from the LCC out to the pad and back. And so I'm going to let Mike talk a little bit more about it, but that's, Eric, at a really higher level, that's what's unique to the wet dress. And Mike, you can add to that.
Yeah, sure. So yeah, the test is a full cryogenic tanking, of both the core stage and of the ICPS, and then also a drain for the stack. It will contain a recycle demonstration where we'll basically recycle our count. Ultimately we'll count down to just under T-minus 10 seconds, right before the engines would fire, and then we'll cut off. It's a good test. Not only of the flight hardware, but also of all the ground systems, like Tom was saying. This is, while we've tested the ground systems, we haven't tested them and the interfaces with the flight hardware. So it's a good test of that. It does run through all of our integrated software together, so both the onboard software and the ground software, and it's an opportunity for the entire test team to be in the firing room with the mission management team, with the engineering support teams at Marshall and at Johnson, and to run through the test. So really, it rings out well. That the obvious difference is we're not firing the engines. That is clearly the biggest difference. But for us on the ground, it's a great chance to get the team and the ground systems wrung out and ready for launch. I think regarding your question of how much time, when do we need to get off? I think you heard Mike Serafin talk. We've got a couple-week window, so we know we've got a couple weeks there where we'd have an opportunity to still get a flight off. But we really need to just kind of get through the test and see where we're at, and at that point we decide when the appropriate time to try launch was.
Yeah, and Eric, Mike got it absolutely right. That's why we won't really be in a position to set a specific launch date until we have a successful wet dress. We really want to see the results of that test, see how we're doing, see if there's anything we need to do before we get ready to launch. And you know that, and I know you know this. This is, and everybody else will tell you this in this industry, that there's a series of activities that we need to successfully complete before we have the opportunity. This is the first flight of this vehicle, and so we are dedicated as an agency to taking this a step at a time, making sure we successfully pass testing that we still have in front of us in the VAB as well as the wet dress rehearsal, and we're absolutely committed to just taking a step at a time, seeing how the test results are, seeing if we have to make any parameter adjustments or anything of that nature. We've been very fortunate. The hardware's performed very well up to this point, but the reason we do these tests is to make sure we're really ready to go. And so just like I used to have a similar job for the shuttle program, we'll take it a step at a time. We'll go through these tests. We'll see where we're at, and we think we're in a good position for the agency really to set a launch date after the wet dress rehearsal.
Thank you. Our next question is from Mark Carreau of Aviation Week and Space Technology.
Thank you. I believe my question's for Tom Whitmire. The federal government's currently under a continuing resolution. I'm just wondering if that imposes any kind of constraint on the planning and preparations for the launch of Artemis 1.
We do not anticipate that will have an impact for what they call a critical set of activities, and so we're exempted from some of that. It may impact some of the other activities that aren't associated with the launch, but it won't. That won't be an impact to the launch for us.
Thank you. Our next question is from Philip Sloss of NASASpaceflight.com.
Thanks. I think this is for Mike Bolger and Kathy Kerner. I know we heard about the SLS program just completed their design certification review last month, and is getting ready for the flight readiness review, the building blocks of the flight readiness review. For the EGS and the Orion programs, can you just tell me where you are? Have you completed the design, sort of the equivalent of the design certification review for this Orion and for the ground systems getting in your lead up to the flight readiness reviews? Thanks.
Kathy, do you want to start?
Sure. Thanks, Philip. Appreciate the question. Yeah, so for this test flight, we have completed our design certification reviews, and what we're really in the process of doing now is finalizing some of the testing and the paperwork required to commit to flight readiness. So we will start that process here in the next few weeks, actually, as we do the march up to the wet dress rehearsal, such that we're ready to support whenever the integrated stack is ready to support a launch. Now, this being a test flight, a lot of the mission activities and the data analysis and the things that we get out of this flight will feed into our design and certification readiness for the Artemis 2 mission when that happens. So we'll be anxious to see this mission be successful and get the test data back from this flight and fold that into our readiness for the next crewed mission. Mike?
Yeah, thanks, Kathy. And yeah, from a ground system standpoint, we really kind of DCR our ground systems, system by system. We've completed 75 out of 76. We've got one that's coming up here in a few weeks related to a pad ECS system. So we're in really good shape. Everything's on track for that. We've accomplished all 4 of our operational readiness reviews, the most recent one being our operational readiness review for integrated test and checkout, which is the sequence of tests that we're getting ready to get into now. So we're in a really good position to move forward with the testing that we've got in front of us.
Thank you. Our next question is from Gina Sansuri with ABC News.
Could you go into, anyone can take this, a little more detail about why the day you launch changes the mission mode?
Yeah, Gina, I think you were kind of broken there, but I think your question was, why does the day of launch change the mission duration?
Yes, that's correct.
Yeah. Frankly, it's a creative solution by our mission planning teams that improved our launch availability. When we initially did our mission availability analysis for Artemis 1, we quickly realized that with what we had as a baseline, a short class mission, which is a half revolution of the moon in what's called the distant retrograde orbit, we could fly roughly a week per month with the interim cryopropulsion stage. So the teams looked at what knobs we could dial to improve the number of days we could launch per month, and they came up with the option to increase the amount of time we spent about the moon in this distant retrograde orbit. And if we go from just a half lap to 1.5 laps, then our mission availability essentially doubles, and we get about half a month rather than just a week a month. And that was again, a creative solution, given the other constraints that we have to deal with. And if I could just kind of go back to a response that I had with Stephen Clark. Stephen, you had asked about window open times and window durations. I will caveat that is based on the analysis data that we have in hand, and the closer we get to flight, the more the team will sharpen their pencils. So those times and window durations could change a minute or two, so I just wanted to add that caveat.
Yeah, and Mike, I would just add, during Apollo, they had the ability to circularize and then go off to the moon, which offers an opportunity every day. We're really looking forward to Artemis 4. We'll have the exploration upper stage on the vehicle. It'll be a very powerful rocket. And that's the point where we can start circularizing our orbits before we do our translunar injection, and that's when we will have a lot more opportunities. So I think we're doing pretty good. We'll have good opportunities here for these first 3 missions, but we're really looking forward to having that more powerful rocket that's on its way.
Thank you. Our next question is from Amy Thompson of Space.com.
Hi, thank you so much for taking my question. I think maybe this is for Mike. I was wondering, based on, I guess, the vehicles Orion and SLS are fueled, are there any constraints on when you have to launch based on that? Thank you.
So there's a number of constraints in play on day of launch. We are limited based on the amount, and Mike Bolger will probably add a few more words on this, by the amount of liquid hydrogen that we have, which kind of dictates the amount of time that we not only can sit on the pad for a given launch attempt, but also the interval between launch attempts. This rocket is so big, and we need so much liquid hydrogen that our current infrastructure at the Kennedy Space Center just does not support an everyday launch attempt. We also have a number of other constraints that we need to look out for. So we need to do collision avoidance screening, and that could actually result in a launch window cutout. When you go to low Earth orbit, you don't have to fly through all the stuff that sits between us and geosynchronous orbit, but we screen against all of the objects in the debris catalog all the way through the point of translunar injection and a little bit past spacecraft separation, which is a little over 2 hours into the mission. So we have collision avoidance. We've obviously got natural environments. We've got weather that needs to be considered. We have a day of launch assessment against the atmosphere that we do, and we'll be gathering data through weather balloons and a Doppler weather profiling system that will tell us the winds aloft and any other conditions that might exceed the vehicle's ability from a structural standpoint to fly through it. So we'll be monitoring the day of launch conditions. We also have some valve cyclings and valve pressurization that we need to manage that can cause us to need to drive the specific time that we go. And then there's a whole host of other constraints that are associated with just general vehicle configuration that are based in what we call launch commit criteria. So we've got a fair number of constraints, and we've trained our ability to work through those constraints and to successfully get to T0. I hope that answers your question.
Yeah, hey, Mike. I'll add just a couple of things. You know, like you said, from an SLS standpoint, you know, we haven't fueled, but we will fuel as a part of the launch countdown sequence. And then, you know, if we were to not go on the first day, we have a 48-hour scrub turnaround capability, and then we would have a third launch attempt 72 hours after that. We are currently upgrading our infrastructure here, adding a new 1.4 million gallon tank, which, you know, initially we were thinking was required for Artemis 4, but we're realizing it does give us some additional capability to improve our turnaround times and support longer launch windows beginning as early as Artemis 2. So that's kind of from an SLS side. On the Orion side, and Kathy may want to pitch in some more, but since we fueled back in our multi-purpose processing facility, we started I'll call it a soft clock of 400 days. We wanted to get a launch off, and that clock would come up in June of 22, but it's a soft clock. We've got an opportunity if for whatever reason we weren't off by June for the engineers to go do the analysis and hopefully get us good to go for launches after that.
Thank you. Our next question is from Lauren Grush of The Verge.
Hi, thank you so much. I'm curious if these updates on schedule for Artemis 1 have any effect on the launch date for Artemis 2, or if that's still scheduled for 2023, and what is the minimum turnaround time that you need between these two launches? Thank you.
Yeah, Lauren, we're still looking at the Artemis 2 schedule. You know, there's a lot of things associated with Artemis 2. This Artemis 1 flight's an uncrewed flight. Artemis 2 is a crewed flight. We have a lot of additional systems that we have in the vehicle that Kathy could talk about. In order to accommodate the crew, we have an environment control life support system and crew displays and other activities. So they're actively working on it right now. As you heard, our European partners have just delivered the service module to support that mission. I think the agencies continue to look at that. We're evaluating the status of that mission, and we'll probably have an update here in a little while on that. But today we're just going to focus in on our first step, which is the Artemis 1 mission, and then a little bit later on we'll get to the subsequent flights.
Thank you. Our next question is from Irene Klotz of Aviation Week.
Thanks, Stephanie. Was there anything that turned out of the integrated modal test or anything else that put the wet dress from November to December?
I can start on that, and then maybe Mike can add some stuff. No, I mean, the integrated modal went really well, and my hat's off to John Honeycutt and his team. Do a lot of the vehicle analysis that we have for structural loads, and they helped lead that. A guy named Dr. John Blevins was the guy that actually helped coordinate that test. It was highly successful, and to be honest with you, they did a really good job. And so the data looks good. We've taken a number of modal surveys of the vehicle in different stages of its being assembled, and therefore we have what we think is a really great catalog that we'll have available for this vehicle in terms of its structural activity. I would say that really when we look at where we are right now and our path forward, a lot of there were first-time challenges, but also COVID was a very significant input on the operations at the Kennedy Space Center. I'll let Mike talk a little bit more about that, but I think they did a really good job, to be honest with you, working through. They had a third surge that came through here, and I don't know if you follow this. Most people, I think, throughout the country are pretty familiar with kind of some of the challenges that we've seen throughout our nation, really. And I think, when you talk about vehicle processing, we have a lot of safeguards that we have in place, CDC and other NASA type safeguards to make sure we're doing the right thing. And Mike has been doing that, and his team has, I think, done a really tremendous job under the circumstances that we've been operated on to be in the position we are right now. And I honestly am very proud of that team, and I'm very proud of the workers down at the Kennedy Space Center and what they're doing to keep this vehicle moving forward. And I don't know if you want to add to that, Mike, but from my perspective, I'm just really grateful and proud of the team down at the Kennedy Space Center.
Yeah, that is how I would describe it too. I'm really proud of the progress that we've made. I mean, we've always been working to a managed to schedule, and as you go through a first-time flow, we learn things. And so, some of the things that we learned in our time leading up to the umbilical retract test were that some of these umbilical mates took longer than we had in our originally original plan. It's a pretty complex interface, and we needed to take our time and we needed to do it right. So we learned that through the getting ready for the umbilical retract test. Obviously, that test disconnects all the umbilicals, so now we've got to reconnect them all back. So what we built into our forward plan was based on the lessons that we learned leading up to it. And similarly, we've got to establish the internal access to platforms that allow us to get inside the launch vehicle. That took, again, a little longer than we had expected, and so we built that into our plan forward. COVID has absolutely, been a part of the story. In Florida in August and September, it hit our area very hard, and obviously, our team lives in the area, and so it hit our team similar to, what we saw in the local community. And so when we had positive cases, it not only took that person out of the workforce at times, but all the close contacts with them as well. So while we worked, while we did everything we could, we wore masks, we kept social distancing to the extent practical. If you were going into our fire rooms, we took temperature checks, we put plastic dividers, we took all the precautions we could. We still ended up with some cases on the program, again, consistent with our community. I'm really proud of the resilience of the team working through that environment. We're fortunate now that it has very much subsided. We had the spike in August and September, but it's much more back to how it was prior to that. And I think we've got a really good plan forward, and I think we're looking forward to executing it.
Thank you. Our next question is from Derek Newsom of Space Scout.
Hi, this question's for Mike Serapin. You mentioned there are two different types of missions laid out for Artemis 1, the long duration and the short duration. Is there any particular between them that the team would favor, targeting the short over the long or the long over the short? Thanks.
Derek, that's a good question. We're going to fly when the hardware is ready to fly, and the value of getting this flight test off and learning from it so that we can do our post-flight analysis and then prepare for downstream missions far outweighs any preference that we would have over flying a short class versus a long class mission. So we're really just focused on flying and being prepared when the vehicle's ready, and we will take the opportunity that's in front of us at that time.
Thank you. Our next question is from Mark Sumner of Daily Coast Media.
Hi, good afternoon. Mark Sumner, Daily Coast. I'll direct this to Mike Serapin. Around the time of the Green Run, there were reports that NASA was looking at bypassing the uncrewed mission and putting astronauts directly on Artemis 1. Did that receive real consideration, and are you still tempted?
Yeah, this is Tom. I'll take that one, Mark. No, I think at one point, that's something that was a long time ago. Right now we are very committed to proceeding as we are proceeding, which is uncrewed test flight. I think that's a good decision the agency made. We always look at different types of things. It's been a long time since we even thought about that, so I don't think. But I think right now, we've been on a very clear path for a while now that we think it's important to get this test flight, and then we've really taken a lot of steps that were really important. We kind of committed ourselves to a full duration Green Run test at Stennis. That was a very big commitment on part of the agency. We're committed to doing this full up wet dress rehearsal. There's a lot of things and other steps along the way that we could have done differently, and I think I'm very proud of the patience of everybody, because the first time you fly a launch vehicle, you have to go through these things and make sure you fully characterize and understand the launch vehicle before we commit the crew. And I think the agency has shown good temperament, good patience, and really taken things a step at a time. And even through some difficult stuff like the storms we had at Stennis last year was very difficult, and John and his team and our team have committed ourselves to taking all the right steps to get this vehicle ready to go. And so I think we are what we think is a really good path. And Mike, I don't know if you had anything you want to add to that, or?
The only thing I would add is to kind of emphasize what Tom said. We routinely look at what kind of different knobs we can dial or what the art of the possible is, and I would just classify that as an art of the possible type conversation. And when we brought the the option as well as the risk profile associated with it compared to our baseline, folks decided to stick to the baseline, and that's the path that we're on.
Thank you. We have time for one more question. We'll go to Stephen Clark of Spaceflight Now.
Thank you for taking another question. I wanted to follow up on an earlier question about Artemis 2. I know you said you want to talk about Artemis 1, but I understood that one of the driving items for a schedule for Artemis 2 is the time it takes to refurbish some of the avionics in the Orion that comes back from Artemis 1. How long does that refurbishment take? And I guess that gives you an idea of the earliest Artemis 2 could potentially fly. Thanks.
Yeah, and Stephen, I'll try that, and I'll let Kathy talk a little bit too. You know, we really will be coming forward with we have an independent schedule assessment that we've done on the Artemis 2 mission. We'll be coming forward with that here in a little while, in a matter of weeks, and so we have a reporting process that we go through. I think that will answer any questions you have about the Artemis 2 mission, and it's independently reviewed, and we baseline because we added some new content, quite frankly, to the mission that make it a more comprehensive mission with rendezvous and prox ops to buy down some risk for the program. And so Kathy can talk a little bit more about it, but there's really a lot of things. People tend to think about like turnaround times and avionics and stuff. I don't look at it that way. I don't think Kathy looks at it that way. We have a whole bunch of stuff we got to do with that crew capsule to get it ready for flight. And so we look at the totality of all the different things, and I don't think any one thing is the thing that really drives the schedules that we're looking at. It's a lot of Eclipse, it's avionics, some crew-specific stuff, some new software, all types of things that are very unique to that crewed mission. And so when we do our independently reviewed schedule assessment, that was all taken into account. And we're not ready to report on it, but we will be reporting on it here in the next few weeks, and then there would be a better time to answer your question. Kathy, did you want to add anything to that?
Yeah, absolutely, Tom. Appreciate it. So the non-core avionics that we're going to reuse between Artemis 1 and Artemis 2 is just one of many factors that we look at as we're preparing the Artemis 2 vehicle. You know, the systems are different on Artemis 2 because we have the environmental control and life support systems that we'll be using for the first time, and those we're learning how to build and we're learning how to install and to test, and so that process is a highly integrated process. So it'll be a lot of first-time activities for the Artemis 2 mission that we'll be doing. You know, Tom also mentioned software. All of the environmental life control and life support system has software associated with it, and that's new and different software than we're flying for Artemis 1. So there are still a lot of activities that we have that we're running in parallel as we approach Artemis 2. Artemis 1 test data and analysis is another factor that we have to take into account. The actual Artemis 1 spacecraft, parts of it will be used in subsequent testing to verify and certify that we're ready to fly crew for the first time. So we have a number of factors that all play together. There isn't any one of those, I would say, that is driving the schedule today. It's really a combination of all of the activities that are first-time activities and things that we're learning and doing for the very first time that really is going to play into when we can launch the Artemis 2 mission.
Yeah, and let me add one more thing, and this is, if you talk to the folks in the Science Mission Directorate, they'll talk about this as well. You know, we had a COVID pandemic crisis, and it's very interesting when you look at that. What we found is that as we're preparing for this Artemis 2 mission, we literally had countries like Germany and Italy that had to shut down for periods of time. We had situations in our country. We get a lot of manufacturing in places like east of Los Angeles and stuff like that, where we really had a difficult period of time, and that really did have an impact on our ability to get some of the hardware in the door. I think Kathy and her team does an excellent job once we have everything that we need to build the spacecraft, but you have to build it in order, and we had a very complex, supply base, and so they, not complex, but we have one that is in parts of the country that were really impacted by COVID. So I think part of the Artemis 2 story is really kind of, just catching up with that as well, that we've got the hardware. The good news is most of it's now available to us in the ONC, and Kathy has a great team team working on it. But we did, that was, and I don't think there's anybody in any of our spacecraft that's in development during this period of time would given you a different answer to that question. That was something that really impacted us.
Thank you. Thank you all for joining us today, and you can listen to a replay of this teleconference in about an hour by dialing 203-369-0188. That's 203-369-0188. The replay will be available for 30 days. The SLS rocket and the agency's Orion spacecraft, along with the exploration ground systems at Kennedy, will be the backbone of NASA's Artemis missions to take human exploration farther into space than ever before. To learn more about Artemis, follow our progress to the pad online at nasa.gov/Artemis program. Thank you again, and have a great day.
That concludes today's conference. Thank you for participating. You may disconnect at this time.